I'm Milan, and this is Thomas. We're gonna have a small workshop here about procedural generation, specifically for Godot 4, and some different algorithms you can employ, some different strategies you can use to mix maybe procedurally generated content and handcrafted, authored content, and how you can best employ that in your own games. So, first, you want to introduce yourself?
Okay, so I consider myself just a sidekick. You'll notice what I do here. Just quickly about me, I'm a software engineer. I'm actually in my day job researching autonomous cars. I have like 20 years of experience in C++, but as for the game dev side, I'm more like an enthusiast and hobby game dev. And my very small claim to fame is that I ported or migrated the GDScript procedural content generation course to Godot 4. But the man of the hour is Milan.
Thank you. Yes, so I'm Milan. I'm a software engineer. In my day job, I work for Open Earth Foundation, who do open source software to fight climate change. But in my spare time, I develop some games, and specifically Sunken Shadows, which is a first-person roguelike built in Godot. We've been working on that for around 2 years. So I've explored a lot of 3D content generation for this project and for some earlier ones. But I love procedural generation. I've been researching it for around 10, 12 years now, and yeah, it's one of my favorite topics. So you want to?
Yeah, I included this one, just there are no confusions. Procedural content generation is not the same as generative AI. We won't talk about generative AI here beyond this point anymore. It's just a small disclaimer. Okay, so this is just a quick overview. We go over a few basics first. Milan will talk a little bit more about specific procedural generators then, and talk a little bit more about his example game, the one he's designing. And then we'll talk a little bit about what workshop projects we've brought for you. So that's the part where you get busy. We try to be done within the next 20 to 25 minutes, and the rest is going hands-on for you. All right, let's start with the basics then. One of the most important ingredients in procedural generation is randomness. So basically, if you want to design a level and want to know should the door in the dungeon be on the left or the right, you could flip a coin. How long should the tunnel be? Well, just roll a die. But this gives you a very specific kind of randomness. It's called equally distributed. And the problem with that is if you take such kind of randomness and want to distribute, for example, some meshes on the ground, you very easily start to have them intersect. And if the meshes are like, I don't know, houses, it looks really ugly if they intersect. And what you can use then is blue noise. That's also called Poisson disk sampling. By the way, the slides will be available later. You don't have to like take down all the links right now. But the general cool thing about blue noise is it's still noisy, so it has some randomness, but there's a relative equidistance between the points. So like if you go back to the houses distribution, at least they won't intersect, and that's what you use blue noise for, one very important ingredient. Right, so this one's for you.
Right, thanks. So a lot of procedural generation systems start with simplex or Perlin noise. For our terms, they're very similar. They have some mathematic differences, and there used to be a problem about copyright, but that's resolved, I think. So the trademark has run out on it. So feel free to use it in Godot, and it's already built in, so great to take advantage of it. The idea here is you can see some of that noise there on the right. It's a very smooth and like has a clear structure, so you can use it to simulate some like natural materials, some natural structures or landscapes and so on. So for instance, if you imagine squishing down that image on the right to like a thinner size, just horizontally, you would already get kind of a wood grain texture, right? Color it brown and you already have wood. So a lot of natural processes can be used like that. On the top right, you can also see some landscape built using simplex noise. It doesn't look quite realistic because it doesn't simulate any of the natural effects like erosion and like weather would have. But those are like additional steps that you can apply afterwards. So for me, like this is a great like starting point that you can start to transform using either mathematical transformations. You can distort it using a different noise function, right? And start shifting it around, apply different modifications to it, and you can get a lot of interesting results with it. So yeah, one of our examples later in the project is based on it. If you want to read more, the Red Blob Games article, linked both there and at the top, will give you a lot of introductions and like hands-on experience since they have interactive demos for everything. Yeah.
Another very historic topic, because this kind of system exists for quite some time, at least in computer science. It's historically old. This one is a system, so the Lindmeier systems is a cool system to generate something like foliage or trees. I've just directly captured these images from the Wikipedia entry. Basically, it's a rules-based system where you have transformation rules, and you start with like a tiny thing. So on the top, it's just like a small dash or line. And then you have rules how to transform this in each generation, and you just keep on generating. It can have random aspects, it doesn't need to. And it's very cool to use Lindmeier systems to create like trees. All right. And now for something completely different. This one here, there will actually be a workshop project for you to experiment with this. Wave function collapse. This is an algorithm which, the term is borrowed from quantum physics. I don't want to necessarily talk about the dead cat here, Schrodinger's cat. If you don't know it, it's like a experiment, not an actual one, just a thought experiment, where you have a cat in a box and an atomic particle which might decay at any point, and a detector connected to something that will sadly kill the cat. And we don't know if the cat is alive or dead as long as we don't open the box, so it's more or less alive and dead at the same time. All right. For the kitten bag, the cat is fine. All right. So on this little example here, you see what this wave function collapse can do. You can have a template and then generate an output that's somehow similar to the template. And you kind of do this by initializing the output space with in quantum physics, we talk about superposition. So you give every cell the possibility to be any tile that's also present in the template. And then you start observing a single template. So you kind of fix down which tile it is. And then step by step, you reveal what's possible around it. And then you repeat this process. So just as a small, tiny explainer, given the tiles at the top, we start on the very left. We know nothing yet, and in the second image, I've fixed down one of the tiles. And then immediately to the right, I know the one tile that goes best here is this one. And then one further to the right, down below, you see another one is revealed. And then at the end, I just put the green tile. But it really depends on the rules, how this goes on. So can a road just end? Can there be a green tile, or does the road continue? Yeah, it's very fun to experiment with, but we talk about this later once more. All right.
Cool. Thanks. So you've seen a lot of different ways how to generate stuff, and you will see a bunch more. However, this is an important distinction that I wanted to bring out early. Basically, just because you can generate, in this example, 10,000 different bowls of plain oatmeal, doesn't mean that they're all interesting and that the player will notice and that it actually has any effect on your game, right? So the keywords that are highlighted here are perceptual uniqueness, and it's like really hard to measure, right? So it's usually a matter more of feeling and like trying it out a bunch and playtesting rather than getting it down to exact science. At least I haven't been able to get there. As long as what you're generating is interesting and doesn't like feel like just randomly thrown together, right? There need to be some kind of red thread through it, right? If you have a character that you're generating and it's meant to be a cleric, let's try to also have the clothing and political beliefs and other things generated for the character also reflect that. So you're not doing random generation, you're doing procedural generation. And that's basically the crux of this topic. So when to choose authored and when to choose generated content and how to combine them. In general, you can't do just one of the two, right? You always have to do both. And you need to find the right balance. And that's different for every game. If you want to make an actually engaging world, the player needs to find some interesting discoveries, which are usually hand-authored content, even then if it's then procedurally adjusted. And the stuff in between is meant to provide pacing, interesting worlds to explore, and just like freedom to the player, but isn't like the core selling point of your game, maybe. But again, that's really different for like a procedurally generated open world game versus like a limited dungeon-based game, or even simpler games that just use graphs for their worlds, let's say. So for instance, what I've chosen for my game is it's really hard to make like authentic rooms that look like they were built by a human, right? So all of the lights are in the same spots and they don't interfere with spawners or any enemies that might be there or treasures that might be there. So we chose to build levels by hand using our own level editor that's based on a grid map in Godot. And then we're just throwing those together by connecting them based off of where the different doors are. I'm going to talk a little bit more about that later. The advantage of that situation is that you have full artistic control over the actual output. Just how it's put together is done by rules and like random generation, which, allows you to control the pacing much more and just have like more artistic control over the whole experience. But yeah, this is very up to the world game, right? So if you don't place any constraints on the game and there are no like gameplay consequences of having weird random situations happen in the world, like for instance in Minecraft, then maybe you're fine with just using procedural placement algorithms that I mentioned here, that we're going to go into later, and that's also one of the example projects. Or you could do it using wave function collapse, right? You can, through that, define some relationships between adjacent objects that you're placing, but it's very much like on a grid and very, similar in the output afterwards, right? It starts repeating a lot. Hierarchical generation is a great approach that works for really big worlds. So you start by basically doing what's called a Voronoi diagram, which is you start with blue noise, you triangulate it, and then you have a bunch of triangles or like polygons, and those you can use to define each of them as a different biome, right? So these are mountains, this is like a marshland, this is ocean. And then you have a much more interesting world structure because it's not just like, straight blocks of your world like it would be in Minecraft. Rather, you have these distinct areas that you can explore. I think this is similar to how Valheim does it for its map generation, which the user can explore, go through them, and find some landmarks in their world. Anyway, so we've already touched a lot on these. I'm going to talk about some small examples about what possible things you can generate to get you interested or give you some ideas of what you could explore next. And then afterwards, we're going to talk about the concrete projects that we have for you. So I try to come up with just like a general approach of like, if you're trying to generate something that hasn't been generated before, how do you get started? And in my mind, what usually helps is instead of trying to come up with it from scratch, you create some example output of what you would like the algorithm to produce at the end. And then you analyze it, right? You make maybe a couple of different versions and you see what the similarities and differences are. You start maybe finding a pattern. Maybe everything is on a grid but slightly moved around, right? Or maybe there's some minimum distances. For instance, in a forest, usually trees aren't that close to each other because they compete for resources. So that's why you can use blue noise that we mentioned earlier to generate the forest pretty well. And then maybe throw out some if there's intersections, if you have larger trees, if you need to, or just define the minimum radius as something that fits for all trees, right? So that would be an example of the structure. Afterwards, of course, you write the code to generate the structure. In that case, you either implement a Poisson algorithm, or my favorite cheat around that is just put everything on a grid and then slightly randomly move everything around, maybe using simplex noise or just like a random generator. And suddenly you can't notice the structure that much anymore unless you zoom out really far. At the end, you probably have something that's like maybe nice to look at, but not really viable for a game, because a game rule usually follows a bunch of rules for its structure, a game world. So you want to enable those rules and basically start constructing and make sure that you validate the rules each part of the step. That way you can, for instance, guide players, so you can spawn healing items before spawning larger groups of enemies inside of a map, and then guide the player's experience through that, rather than just having him run down a straight corridor. And what I mentioned earlier, that's always good to do at the end, right? Find some, even if the whole world is generated and looks great, put in some pre-authored scenes just so you can, you know, have like a bonfire from Dark Souls there, or some nice moment for people to relax and release tension maybe. That's another good point. Or just like as a set piece and you want to really show it off. Yeah, all right. So next topic is procedural spawning. Again, there's going to be one project there, just exploring the Proton Scatter add-on for Godot, which is really helpful for just like throwing a bunch of objects randomly across a landscape inside of certain boundaries or shapes and defining them with rules. So again, you start with building a set of rules. That's, I guess, always core to procedural generation, because you don't just want to do it randomly. You want to invoke some structure and some intent. With those rules, as I've mentioned before, if you're doing like a world generator, you can start with biomes. Either all of those are like rectangles, or they're actually, you know, polygons generated from Voronoi noise. You use this input, could be simplex noise, could be Voronoi, as I said. You start adding structure, like for instance, you could start defining roads, or you first you spawn down settlements, then you connect them via roads that try to like avoid mountains maybe, if you can. As I mentioned, you can spawn trees using blue noise, but you only do that where there are no roads, or if you generate the roads after, you remove the trees that are in the way. You remove all of the trees that are on terrain that's too steep, so this is like a 3D example, right? But if the terrain goes down too much, trees have a hard time finding their roots there, so you want to remove them at slopes, and you probably also want to remove them on a certain elevation, because at the tops of mountains usually you have like snow or like, you know, alpine trees, but not too much normal trees anymore. And a lot of this can be done via code. So for instance, if you're using a multi-mesh, that's also what Proton Scatter, the add-on that's used for the example project, is based on. But if you just throw down some code to generate like a vector array, which is like the transforms then, positions maybe, or even rotations if you need them, maybe some custom colors that you can store in the instance data, and just throwing all of this data into a multi-mesh already gives you a pretty vibrant world. Or if you don't like doing that via code, you can try the Proton Scatter add-on that's part of one of our example projects, and just do it all via UI, define some shapes, and you get a pretty immersive scene quickly. So I think this is one of the last concepts before we get to the actual generators. If you are doing 3D worlds, and specifically if you're doing spaceships or any kind of like natural landscape, Greebling is a great concept to look at. Basically, you always have a certain hierarchy of decoration objects on others, right? So in this example, we already have the trees, which were spawned using blue noise, and you limit them using terrain elevation and so on. And then around them, you distribute some bushes just to make them blend more into the landscape. Around those bushes, or maybe around the trees, you also distribute mushrooms to give it, more of a forest vibe. And then you already have a pretty nice way of representing those natural rules that, usually mushrooms and trees live in harmony, so they are much more likely found closer together, and it also looks much more natural. But you can also do this for man-made objects, for instance, for spaceships. That's where the term Greebling actually comes from. I believe it was invented by George Lucas, just to describe how they put small boxes and then other boxes on the boxes and so on to create the starship effects for the original Star Wars movies. So it's a very similar concept. Feel free to also give that a look. Yeah, just if you want to have your world feel a bit more real and not create too many complex rules, this is an easy way to get around that. And mostly we talked about like 3D and 2D worlds for now, but you can generate pretty much everything. So this, by the way, is a screenshot from a great article from Inigo Quiles. I hope I'm pronouncing the name right. But this is a very simple technique that also works in a shader, but you can also do in GDScript to generate random color palettes. And if you've ever tried that just by doing like random RGB values, usually that looks pretty ugly because RGB is not a great model of our like perception of color. So if you do that in the HSV color space and follow some of these, like basically this is just like a matrix of sine and cosine that you use here. So it's also very cheap to calculate. And you get pretty beautiful colors depending on like the input values that you give it with like A, B, C, D. So that's a great way if you want to like procedurally color animals that you're generating or plants or something. This is a great way to do it and just like consistently follow the same palette. Yeah, all right. So I'm going to quickly talk about my own game, which is Sunken Shadows. I've been working on that for around 2 years. So this is a screenshot with the PlayStation mode on. That's just a post-processing shader at the end. What it is like a 3D first-person roguelike set in a ruined city under the sea, which you can imagine to be similar to Atlantis. That's the second biome of the game. You can see an enemy, which is like a blobfish that has an energy shield around it, some glowing corals, and so on. Anyways, we're aiming to release our first public demo in 2025, most likely in February. And yeah, I can talk a little bit about how our generator works and how we got here. So yeah, basically what we're building is a 3D dungeon. The nice thing that we have, which has been around since the start, when we started Sunken Shadows as during a game jam, is a level editor. It's a very simple player controller mixed with a script for a grid map. And all it does is do a raycast into the grid map, and if it hits something, it places a new block from the one that you've currently selected. So you've got Minecraft-like controls, and it's very intuitive and easy to build a level just by like flying around and clicking. This allowed us to build like a bunch of rooms at once, so we can try out our generator because it didn't really work if you just had like 2 or 3. Repetition was a little bit intense, and some of the concepts like neighboring rooms and assigning certain positions just require a bunch of different room designs. So what we're doing is basically we just start with a start room. We go down once to basically start the first dungeon, and each of our so-called dungeon layers is basically like a horizontal plane, even though the rooms might be going up and down a little bit. It's all constrained. And then, yeah, so we start with one room. We are using a drunkard walk algorithm, which is just saying you are at the spot, choose a random direction that hasn't been chosen yet, that's adjacent to you, and then continue. Right? So it just finds like a random pathway through a grid, basically. And we're making sure that we don't overlap other rooms. And if necessary, we push them outwards so we can define some space. We have also rules about which rooms can be spawned next to which other ones. So for instance, these are very similar to The Binding of Isaac if you've played it, but for instance, we don't want shops or treasure rooms on the main path instead, in case they need to be locked off for balancing reasons. So we always place them in exactly one room long offshoots, and we basically just prevent the generator from placing any adjacent rooms afterwards anymore. So you have only one entry into this room, and you jump back to the previous room and then continue from there while we're doing the drunkard walk. That's basically all the magic, and you can introduce a lot of rules using just like, at which point and by which conditions you place certain types of rooms. And yeah, basically we just go down layer by layer, just through like what also works for our narrative. And we generate 2D layouts of just like rectangles for each room with their size. And we define the exit and entry points for the start and end room of the floor, just usually a mini boss, the exit room. And at the end, like once all of those layers are generated, we just move them around until the start and exit points of two adjacent layers are over each other, basically, and we connect them using a long tube, which is just like a four-sided cylinder, basically. So just like a long block that goes down and prevents you from going outwards. And then, since our player controller falls pretty fast, since it's like a robot or a mech, that basically solves the problem of like the large distances between them if there's too much difference in the height of rooms. Yeah, all right. So there's some final concepts that we employed here to make this more efficient. First off, instead of building like a ton of different copies of the same room with different decorations, so there's not too much repetition, we actually modify them at runtime. So since it's a grid map that you're placing, it's very easy to modify that using code. And you can say, hey, if it's this lamp, give it a 50% chance of being another type of lamp, or we just randomly place around some algae, let's say, or some plants for decoration, just to break up the scene a little bit and ease the repetition. And afterwards, once we're done with the modification, we do something called baking. So basically, grid maps, if you've used them in Godot before and you do larger scenes, they're kind of slow. So what we do is we remove all of the 1 by 1 by 1 meter blocks inside of a mesh and merge them together into a mesh that basically has a sprite sheet texture. So it's only one mesh with one material rather than a bunch of different meshes that are just like all grouped together. So that basically brings us from like 70 FPS on like a lower end laptop to like 120 or 160, just because like most of the geometry is already gone and like in a very simple to optimize schema. All right. Any questions until now? Because we're gonna go into the projects and talk a little bit about what you can do yourself in the meantime. But does anybody want to interject or have any questions about the topics we discussed? Yeah, go for it. Yeah, I'm not the biggest fan of it, of course. I think a lot of people will share that opinion. I don't like what it does to artists, but also this is very different, right? So you still use real artists' work, you still work with them the same way, just the level design is a little bit easier. You still, need all of the knowledge of level designers, right? And you still need them to build all of the hand-built scenes. It's just the stuff between that's usually like tedious to build, just placing a bunch of plants on the road, right? You can automate that a little bit using algorithms, but it doesn't mean you're generating your whole art. Right. Anybody else? Cool. Yeah? No, you would have to implement it yourself. So I linked some tutorials there. I'm sure there's already an existing implementation somewhere on GitHub, but we'll have to check. But it's also very straightforward. The Poisson algorithm, you can look it up on Wikipedia. It's like a small block of text, and it's very straightforward to implement. All right, so these are our project suggestions. We've got one example project, which Thomas is handling, which is about wave function collapse. So you can play around with generating 2D worlds. Do you want to talk about that a little bit or later? Yeah, okay. And then we've got two different ones, I guess 3 different ones if you really want to get experimental, for doing 3D worlds. So there's one that is less code-focused and more like UI and trying out the tools, which is using proton scatter. And then, you create your own world basically based off of existing meshes that you then spawn in like, procedural ways. The second project would be to actually generate your own meshes. That could be landscapes, that could be other things, with those tools that Godot already provides that make it very easy to make your own geometry just using code. And yeah, for instance, you could do height maps, you could do floating islands. I've got a generator for that if anybody's interested. And the last step, which there isn't an example project for, but if you're already very advanced and want to give it a try, is generating meshes or maybe worlds using compute shaders and like the buffer output that they have into a texture, trying to use that to offset a mesh maybe, or finding other interesting ways to work with a compute shader. All right.
Yeah, there is not so much to say about the actual project, other than I've defined 3 labs inside the project. By the way, there will be a link at the end to the repository. And the first lab is really more about playing around with wave function collapse. The second one is something where you're invited to enhance the presented implementation. And the third one gives you enough information to be able to implement your own. Yeah, the implementation I provided is very easy. If you're an experienced programmer, you might probably not even like it very much. And then the lab 3 is for you.
All right. The next project example is this one. This is actually the example scene that you can try out and customize for yourself, start using your own meshes and so on. But yeah, basically we're using the Proton Scatter add-on from the Godot asset library or GitHub in order to spawn some meshes in the world and start defining some of those procedural rules, maybe even creating some of those scatter blocks using code. That's an interesting way to combine like the ease of use of like this add-on and the UI components with the flexibility of procedural code. The slides here are available both on the Godot schedule website, so it's attached to the talk. But we also have a QR code in a second if you just want to scan that. I'm not going to go through all of the steps in detail. Basically, you just clone the example project that we have. So Proton Scatter is also provided in Dimmed. Didn't update the slides here yet. And yeah, play around with it, see what you can do, maybe define some exclusion zones, maybe create some larger landmass and try to make more interesting landscapes using it. Next project would be to generate some of your own meshes. So these are some examples. These are not procedural. These are examples from the basemesh.com, which is a site where you can just download geometry under a CC0 license. It's not textured, but it's UV mapped, and it's very useful. Yeah, basically, you also download our example project, or you just make your own, and you start generating. So we have an example for making landscapes. We don't have one for generating meshes, but you can use the same technologies described there, and that are an example code to make any kind of mesh, right? You just don't want it to be a plane then, you want it to be something more complex. What's also good to start here with this approach is create a base mesh in Blender, let's say, or just use like the default Godot cylinder and then subdivide it and move around vertices based off of formulas, right? So the screw down here, you could simulate that using a sinus function in like a vertex shader if you wanted to, or you could do it in GDScript code with the surface tool, and then like adjust the other geometry around it, and you could make a generator for a screw if you wanted to, right? So just some examples to get you thinking, but you're welcome to make anything you want. And if you want to, send us the results, any meshes or code that you can upload to our MIT Lessons project. We'll show that around and yeah, start talking about that afterwards at the end of the course. And if you're really advanced, you can start building a compute shader and generate some cool stuff with it, because you have a lot of compute power available then from the GPU that you can use to run all of your procedural algorithms for, let's say, making a really cool height map for terrain. But this is the most advanced, so if you have experience with writing shaders or like GLSL, then I would recommend this. Otherwise, it's probably a little bit out there. All right, so if you want to get started, this is the QR code, but you can also just type in that URL. That's the repository with all of our example projects, and let me know if you have any questions. Thanks, everyone.